Assalamualaikum and hi to Dr. Rose and my fellow friends. I am Nur Aisyah Inara binti Ahmad Nazri. Today I'm going to talk about ocean ion fertilization. What is ion fertilization? Ion fertilization is defined as an effective method for stimulating oceanic carbon sequestration through biological pump in ion-limited, high-nutrient, low-chlorophyll region. How did they know about the atmospheric gas composition in ancient times? Analysis of trapped air bubbles in Arctic-Antarctic ice cores have revealed that atmospheric carbon dioxide almost 180 ppm during the last glacial maximum was much lower than during pre-industrial time, which is 280 ppm. How did Martins come to this finding? Since earlier of the Industrial Revolution, human activities have caused a rapid increase in atmospheric carbon dioxide, which causes major greenhouse gas from about 280 ppm to about 400 ppm nowadays, which turned to global warming and ocean acidification as indicator to reduce global greenhouse gas emission ASAP. Since anthropogenic activity are uncontrollable, the scientific agree that the negative outcomes are globally tough issue that should be settled for the sake of living things on Earth. Also, in the context of increasing global and political concern associated with climate change, it is valuable to examine the validity and uses of the artificial ocean ion fertilization experiment. What is the main objective of this OIC? The objective is to investigate the biogeochemical responses of ocean environment towards artificial ion addition. Here, the 13 artificial ocean ion fertilization area that has been ran, while this is the 6 natural ocean ion fertilization area that has been ran. Why are these areas have been of interest by scientists and industry? Martin hypothesized that during the LGM increase, does input relief ion limitation and thereby considered enhance the biological pump in HNLC regions, particularly in Southern Ocean. Since Martin's hypothesis was first published, there has been many interest in ocean ion fertilization because only a small amount of ion is needed to stimulate a strong phytoplankton response. Therefore, much of the investigate focus has pointed on the artificial addition of ion to HNLC regions as a means of enhancing carbon fixation and subsequent export via the biological pump. The Martin suggests that ocean ion fertilization could be an effective method for stimulating oceanic carbon sequestration through the biological pump in ion-limited, high-nutrient, low-chlorophyll region. This is because primary production can be significantly enhanced by the artificial addition of ion. For example, to relieve and resolve the problem of global warming is by reducing of atmospheric carbon dioxide by enhance the biological carbon dioxide uptake, including ocean fertilization and the direct capture or storage of atmospheric carbon dioxide through chemically engineered processes. One of the most attractive methods, ocean fertilization, which target the drawdown of atmospheric carbon dioxide by nutrient addition, for example, iron, nitrogen, and phosphorus, to stimulate phytoplankton growth and then carbon export to the deep ocean or sediment via the ocean biological pump. The ocean biological pump is frequently represented as a single combined process whereby organic matter produced by phytoplankton during photosynthesis in the surface water is quickly transported to intermediate in or deep waters. Iron acts as essential nutrient to stimulate the uptake of nutrient for phytoplankton growth in the subarctic North Pacific, Equatorial Pacific and Southern Ocean, which are well known as high nutrient and low chlorophyll region. Phytoplankton can completely utilize the available nutrient, particularly nitrate, for photosynthesis due to a lack of iron. As a consequence, primary production in this HNLC region is relatively low despite the high availability of nutrient. Total of 13 artificial OIF experiments have been conducted in the following areas. Several limitations were listed according to the experiment except EIFEX, LOHAFEX series 62 and FEEP. Here is the list of experiments that achieved the objective and some did not achieve the target. Also, there is experiment that fully success and unsuccess. There's a few ideas on how to improve for future OIF experiment. Firstly, tracing of the ion fertilized patch using both physical such drifting buoy and biogeochemicals such as sulfur hexafluoride, photosynthetic quantum efficiency and partial pressure of carbon dioxide tracer. Number 2, monitor of side effect on marine ecosystem including production of climate relevant gases such as nitrous oxide, dimethyl sulfide and halogenated volatile organic compound, decline in oxygen inventory and development of toxic algae bloom with optical sensor equipped autonomous moored profilers and or autonomous benthic vehicles. Number 3, shipboard observation extending over a minimum of between 40 days with multiple ion injection. And lastly, application of neutrally buoyant sediment traps and application of the water column derived thorium-234 method at 2 with autonomous profiler equipped with an underwater video profiler and a transmissometer. That's all from me. Thank you.